All right, folks, it's back in action here. In this video, we're going to go through some examples of graphing sine and cosine. We're going to cover all of the potential elements that you might need to include in a graph, and depending on your teacher, you may or may not need to include all of these elements. So it's going to depend on what your teacher's expectations are. So you'll just have to listen in your class depending on what that is. So the first thing that I like to do is take a look at the equation, and I like to look at all the potential transformations. So a vertical translation, remember, that's going to be an addition or subtraction on the front or the back end. We don't see any here, so we're just going to write ourselves a note of none. Our amplitude, we're going to find is the coefficient in front of the sine or the cosine, but amplitude is an absolute value, so our amplitude is only a 3. A reflection will be the sign of that coefficient. So if that coefficient is negative, we have a reflection. So in this problem, we do. Our period, we're going to determine if there's a period change if there's a coefficient on the x value. Now, this one does not have a period change, so we can just immediately identify our period is 2 pi. Our starting point is going to mean whether there's been a horizontal shift, a phase shift. So when we look at this entire expression, I always like to just grab the entire expression, x plus pi over 4, and I would take the entire expression and set it equal to 0. We're setting equal to 0 because the parent sine function would start at 0. When we solve that, we're going to find that our first key value is going to be a negative pi over 4. Now, the distance between those key values, we're going to need to spread this out nice and evenly, and our graphs are going to be divided into 4 key pieces, just like our unit circle is divided into the 4 quadrants. So we're going to take our period, and we're going to take that period and divide it into 4 pieces. So 2 pi over 4. Now, sometimes you're going to want to reduce that to a pi over 2. In this case, I am not going to need to reduce it to a pi over 2 because this 2 pi over 4, this denominator matches the denominator of my starting point. So it's just going to be easier for us to keep it like that. Now, we need to calculate those remaining key values. So we're going to start here at this negative pi over 4 that we already calculated. That'll be our first one. We're going to add to this the 2 pi over 4, and we're going to find 4 more values. So just adding that together, we're going to get our next value is going to be pi over 4. Add another 2 pi over 4, we'll get to 3 pi over 4, then 5 pi over 4, then 7 pi over 4. Now, this common denominator here is what's going to help us figure out what each of our tick mark values should represent. So I'm going to make each tick mark value a pi over 4. So my first value here is at a negative pi over 4. Then I'm counting over 2 pi over 4. So my next value is actually right here because each value is each tick is 1 pi over 4. So I'm going to get to right here. Now is when I want to keep that as a nice and reduced value. Then my next value is 2 more pi over 4s later, so a 3 pi over 4. Then a 5 pi over 4. And my 7 pi over 4. So I had my initial value plus 4 more. Now, to do the graph itself, what I'm going to do is I'm going to think about how my normal sine graph is shaped. So normally sine would start on the center line. There's no vertical translation. So normally sine would start on the center line and then would go up. But since our graph has a reflection, we're going to start on the center line and we're going to go down. Now our amplitude is 3, so we can decide whether or not we want use each tick mark to represent or whether we want to spread our graph out more. I'm just going to go ahead and keep this one as each tick mark representing 1, and that's totally fine, but sometimes you might want to spread those out. So I'm going to start right here at 1, and then I'm going to go down 3 units, 1, 2, 3, but remember I need to be at this pi over 4, so I'm going to be right here. Then I'm going to come back to my center line. Now I'm going to go up 3, and then I'm going to come back to the center line. Connecting those, each little piece should look like a little semicircle. Now, This graph is going to go on and on, so we should put some arrows there on the end. Sometimes your teacher will want you to continue this again in this direction, or maybe make another 2 periods and keep going. Again, depends on your teacher's instructions. So our domain of a sine graph, remember, is always negative pi over negative infinity to positive infinity. The range we can now read on our graph is a -3 to a +3 because this graph has been stretched out. Okay, let's do another one. Let's look at a cosine graph. Again, it's always nice to go through those various transformations first, identifying those. Does this have a vertical translation? Yes, I can see there's a value added or subtracted. This vertical translation, because it's negative, is going to be a down 3. The amplitude, when I look at this coefficient on the cosine, is still a 1. So my amplitude here is still just going to be a 1. There's going to be no change there. It's the absolute value of that a, so it's going to be a 1. Remember, reflections are found by the sine of that value in front of the cosine, so there's no reflection on this one. Our period, remember, our period might change, and we're going to read that by looking at this coefficient. This time I do have a period change, so I'm going to do a 2 pi divided by that coefficient of a 4. So now my period is only going to be a pi over 2. So instead of taking a whole 2 pi to finish, it's going to finish in 1/4 of the time. Now, to find my starting value, notice that we have both a period change and a horizontal shift, a phase shift. So we're still going to take this full amount, 4x minus 2 pi, and we're going to set that equal to 0 because the parent cosine graph starts at 0. Now, we're just going to solve this little equation. 4x equals 2 pi. X is going to equal 2 pi over 4. That's going to then, of course, reduce to a pi over 2. So now, don't get confused. This pi over 2 is how long the whole graph is going to take. This pi over 2 is where the graph itself is going to start. Okay? Those are different things. Now, the distance between the key values here. Again, we're going to take this period, and we're going to divide that period into 4 pieces. This is what's going to help us figure out how far apart our values are supposed to be. So our period of pi over 2, when we divide by 4, that's going to be easier to multiply that by a 1 over 4. Didn't mean to write a pi there on the top, sorry about that. So we're going to multiply this by a 4th. That means that all of our values are going to be pi over 8 apart. That's what's going to help us then figure out what to make our tick mark values. So our starting value, pi over 2, it's where our first tick mark is going to be. We're going to add to that a pi over 8 each time. Now we're going to need to get some common denominators. So I'm going to multiply that 4 over 4. So my first value is going to be at 4 pi over 8. Okay, so it's going to be a pi over 2, but a 4 pi over 8. So when I do this, now I'm going to start adding that pi over 8. So I'm going to get a 5 pi over 8, a 6 pi over 8, a 7 pi over 8, and an 8 pi over 8. Remember, we have our first value, and then we find 4 more. So now let's take a look. If we make each value, each tick mark equal pi over 8, that's going to be our smallest value. It's going to be the easiest to count that. That means I'm going to start at 4 of those over. 1, 2, 3, 4. Okay, so this would be my first one. Okay, so this is my 4 pi over 8, or pi over 2. Now, I can add a pi over 8 to that each time, and I'm going to get 1 here, 1 here, 1 here, and 1 here. So this is going to be pretty tiny here. Now, this may or may not be easy for you to read. It's going to be totally up to you whether or not you want to spread this out more. You could make your tick marks farther apart, okay? But I'm going to go ahead and I'm going to leave this kind of all scrunched together, and that's okay with me. Now, this one had a vertical translation. So what I want to do is I want to draw in that little horizontal line to represent this is where my new quote-unquote center line is going to be. Okay, and I'm going to move these dots down here. Now, a cosine graph does not start on the center line. It's going to start either above or below. Now, our graph does not have a reflection, so we're going to start above our center line. So I'm going to put a tick mark there to start above. Then my cosine graph is going to come to my center line. Then it's going to come down below. Then it's going to come up. Then it's going to come to here. So here's what I want you to notice. This graph is going to look really tiny here. Now, that should kind of make sense because our graph was supposed to finish pretty quick anyways. If your teacher wanted you to continue and maybe make another period, we could just continue this on backwards. And notice that we could get another period of cosine. And what I want you to notice is that this cosine graph then would actually end up right here at the y-axis where cosine would normally start. So we have shifted ours over, but it could actually be written as a graph that does not have a shift at all. So there's lots of ways that you can do this. And again, if you wanted to spread these out, you can. Your teacher will most likely also want you to label these as this 5 pi over 8, reduce that 6 pi over 8 to a nice 3 pi over 4, then your 7 pi over 8, and of course 8 pi over 8 is just pi. So you're going to have some choices there on how you want to do this, but this is probably the easiest way to figure out what those tick mark values are. Our domain, still negative infinity to positive infinity. Our range, since we didn't scale any of these values, we can see we went down to a -4 and we went up as far as a -2. So our range is a -4 to a -2 inclusive. So that is all of the various potential elements that you might need for a graph, and we'll do more examples in class.